All right, today we're diving into something big. We're talking about a blueprint for the future of science itself. And this isn't just about predicting things better. It's about building a system that can actually learn how to discover. Now, this statement right here, this is the core idea. It's a huge shift in thinking. We're moving away from just building better crystal balls, simple prediction tools. We're moving toward creating something that can actually learn how to learn, kind of like a real scientist does. So you might be asking, why do we even need something like this? Well, it turns out modern science has a pretty big problem. It's this weird paradox where all our progress is actually starting to slow us down, right when we need to be hitting the accelerator. Okay, so here's the problem in a nutshell. Imagine you're trying to drink from a fire hose. That's what science feels like right now. We are publishing millions of papers every single year. The amount of data is just staggering. But, and this is the crazy part, real, game-changing discoveries, they're still slow, they're super expensive, and a lot of the time, they're held back by our own human biases. So we're basically drowning in data, but we're starving for actual understanding. But what if there was a better way? What if we could build a completely new kind of engine for science? Well, that is the big idea behind something called discovery intelligence. And I want to be clear, this isn't just another AI app you download. No, it's a whole new way of thinking about how we solve scientific problems.
So, what is discovery intelligence? Officially, it's a self-learning scientific ecosystem. Now, the keywords there are ecosystem and self-learning. Ecosystem means it's not just one thing, it's a whole system working together. And self-learning, that's the magic. It means it learns from actual lab experiments. It can tell you why it thinks something is a good idea. And, this is the best part, it gets smarter and smarter with every experiment.
And it all works in this really cool 5-step loop. Okay, so first, it digests all the existing data. Then, it starts making predictions about new stuff, say, new molecules. Step 3, it actually tries to explain the science behind its predictions. Then it comes up with brand new ideas for scientists to test in the lab. And here's the crucial final step. It takes the results from those real-world tests and learns from them. It creates this amazing closed loop where the AI and the lab are in a constant conversation, making each other smarter. Okay, that's the big picture. Now, let's pop the hood and see how this thing actually works. What are the key pieces that make this whole self-learning engine tick? All right, rule number 1. It all comes down to the data. I mean, everything. You know the saying, garbage in, garbage out? Well, that's especially true in science. So this whole system is built on a rock-solid foundation of structured, verifiable, and reusable knowledge. Every experiment, every data point is recorded in the exact same way. That makes the information credible, you can reproduce it, and it becomes a real asset. It's basically the source of truth for the entire engine. Okay, now for the fun part, the brain of the operation. This is where it gets really clever. Instead of betting everything on one single know-it-all AI model, the system uses what they call an ensemble brain. Just think of it like having a whole team of experts in a room. You're not just getting one opinion, you're getting a second, a third, a fourth, all from different models with different perspectives. And why do this? Well, it just makes the whole system way more reliable. A single AI model, that's a high-risk bet. It could have a weird bias or a massive blind spot you don't know about. But when you have a whole ensemble of different models, they kind of balance each other out. Their weaknesses are offset by their strengths, and what you're left with is a much lower risk, more robust insight. It means you can actually trust the recommendations. And this leads to what is honestly a total game changer for using AI in the real world. The ensemble brain doesn't just spit out an answer. It also tells you how confident it is. It knows what it doesn't know. And that ability to communicate its own uncertainty, it's revolutionary. It lets a scientist know, okay, this is a sure thing, versus, this is more of a long shot. Okay, so we have good data and a smart brain. But this next part, this is the real engine room, the most powerful piece of the whole puzzle, its ability to get smarter all by itself. And it does this using something called the active learning loop. Remember that loop we talked about? This is it in action. It's a virtuous cycle. The system makes a prediction. It proposes a new experiment to test that prediction. A scientist runs the test in the lab. The results get validated and boom, fed right back into the system. The models retrain. And with every single cycle, the whole engine gets smarter, more accurate, and better at hunting down the next big discovery. Okay, so we've been deep in the technical weeds. Let's pull back up to 30,000 feet. What's the payoff? Why does this whole thing matter? Why does it change everything?
Well, the benefits are huge, and they affect everyone. First up, scientists. For them, this is like putting the process of coming up with and testing new ideas on hyperdrive. Then you have companies. They get to cut their R&D costs like crazy and get new products out the door years faster. And finally, there's us, humanity. This means we get the things we desperately need, new medicines, sustainable materials, you name it, so much faster.
And what's so cool about this is that the underlying idea, the architecture, it's not a one-trick pony. It isn't just for, say, finding one type of material. It's a universal engine for discovery. You can take this same basic blueprint and apply it to pretty much any scientific field. We're talking new drugs, better batteries, next-gen computer chips, the works. And that really brings us to a powerful closing idea from the person who designed this system. You know, for most of human history, our biggest discoveries have often been, well, accidents. A little bit of luck, some serendipity. The whole point of this is to change that, to stop waiting for accidents and start making discovery a deliberate, intelligent process. So I'll leave you with this question to chew on. If we can actually do this, if we can build an engine that truly learns how to discover, what's next? What are the biggest mysteries out there that we could finally solve? It's an exciting future to think about. Thanks for tuning in.